Hi guys, welcome to another video clip of MrLopezClasses.com. This video clip is for our course of marine corrosion. In this particular video, I am going to explain the procedure to select the sacrificial anodes according with the type of hull, the material of the hull, and according with the type of water. The summary of this great course is in this wonderful poster. You remember, we have poster for the analysis of the coolant. We have a poster for the oil sample analysis. We have another wonderful poster related with the codes, the OBD2 codes, the codes. And we have a new poster related with the selection of the sacrificial anodes. Founded those posters in my webpage, www.mrlopezclasses.com. You select on top posters and you go and you select the poster that you wanted. There are other wonderful posters with pictures related for air condition, for fuel injection systems, a lot of pictures, a lot of posters. You can buy those posters in my webpage or in my Facebook page also. We are going to start with the analysis of the sacrificial anodes. Zinc is the first one. The first one is zinc. Zinc, this is the formula for the military formula for zinc is mil A 1801K. This is the military name for that wonderful alloy. It's a zinc alloy. Okay, with what voltage produce that alloy, that zinc alloy? The potential electrical of this alloy is minus 1.05 volts. Remember that we try to find excellent alloys with lower electronegativity, with lower level of energy, because we need a sacrificial anode. The sacrificial anode is less noble, less energy in comparison with the metal that we want to protect. Okay, in this particular case, the zinc alloys generate minus 1.05 volts. It's a low voltage. This is good. This is good. It's a good sacrificial anode. Okay, this is zinc. And now what happened with zinc in salt water? Zinc alloys are recommended in salt water environments. They are highly recommended in salt water environments. What happened with zinc in fresh water? Zinc alloys, they offer poor protection in fresh water. Yeah. In fresh water, it's not the best. The protection is a poor protection. And what about in brackish water? The zinc alloys offer a acceptable, is a fair protection in brackish water. In other words, the zinc alloys work in salt water and brackish water. In fresh water, no, it's not recommended. Okay, we are going to check what happened with the zinc with inboard hulls. What happened with the zinc alloys, the sacrificial anodes in zinc for inboard hulls. There are 4 types of inboard hulls: aluminum hulls, fiberglass hulls, steel hull, and wood hull. We are going to start with the aluminum hull. What happened with the zinc sacrificial anodes in zinc alloys? If I have an aluminum hull. If I have an aluminum hull, the zinc anodes are recommended in salt water with aluminum hull. In salt water, perfect. The anodes of zinc. The anodes of zinc are not recommended in fresh water with aluminum hull. What happened with the fiberglass hull? In fiberglass hull, the zinc anodes are recommended in salt water. In fiberglass hull. The zinc anodes are recommended for fiberglass hulls for brackish water. In both of them are recommended. In fresh water, no. In salt water and brackish water, yes, they are recommended. Sacrificial anodes in zinc alloys for fiberglass hulls. Now we are going to continue with aluminum. Other wonderful alloy. That alloy is the MIL A24779SH. This is the military nomenclature for that aluminum alloy to fabricate anodes. Okay? What voltage produce that aluminum alloy? Produce minus 1.1 volt, negative. Oh, it's a little better than zinc. Yeah, this is a little better. Of course, if the anode, the sacrificial anode, is less noble, it's better. This is better than zinc. It's minus 1.1 volt. Okay, we are going to check aluminum in salt water. Aluminum anodes are recommended in salt water. Good in salt water. And we are going to check right now what happened with aluminum in fresh water. Aluminum anodes offer a fair protection in fresh water. It's not the best in fresh water. Okay, but they protect. And what about aluminum in brackish water? Aluminum anodes are recommended in brackish water. Okay, they are recommended in brackish water, in salt water, in fresh water. The protection is poor protection. Okay. What happened with the aluminum anodes for inboard hulls? For inboard hulls, we are going to check what happened if the hull is in aluminum. If the hull is in aluminum, the aluminum anodes are recommended in salt water with aluminum hulls. The aluminum anodes are recommended in fresh water with aluminum hulls. And the aluminum anodes are recommended in brackish water with aluminum hulls. In other words, highly recommended in all type of waters with aluminum hulls. Perfect. And now we are going to check what happened with the fiberglass hull. Aluminum anodes are recommended in salt water with fiberglass hulls. Also are recommended in fresh water with fiberglass hulls, and also are recommended in brackish water with fiberglass hulls. Excellent. The performance of the aluminum alloys, the aluminum sacrificial anodes in aluminum alloys. Excellent. And the fastener recommended is a silicon bronze. Okay. This is for aluminum anodes in fiberglass boat. And now we are going to continue with magnesium. This is the other alloy. The military specification is MIL A21412. It's a magnesium alloy special for fabrication of sacrificial anodes. Okay, we are going to start with the voltage produced. It's minus 1.6. It's the highest voltage produced. Of course, it's the less noble alloy. For that reason, you need to be careful with those magnesium alloys, because in some cases produce overprotection. In some waters and some materials of hulls produce overprotection. For that reason, it's not recommended in some situations. Yeah, in terms of electronegativity, it's the best. It's the less noble alloy in order to protect other metals. But in some cases, produce overprotection. What happens if you have overprotection? If you have overprotection, you produce a lot of oxide of magnesium covering the surface of the other metal, and probably this is not good. Okay, we are going to analyze right now. This is the voltage, minus 1.6. You remember aluminum, minus 1.1, and you remember zinc, minus 1.05. In other words, the best is magnesium in terms of the level of energy, the level of passivity. It's less noble magnesium, and after that is less noble aluminum, and after that is less noble zinc. Okay, the best in that factor is magnesium. And now we are going to check what happened with magnesium. Okay, the magnesium anodes are not recommended in salt water because produce overprotection. I explained before. In salt water, no use magnesium anodes. What happened in fresh water? The magnesium anodes are highly recommended in fresh water. This is the area where the magnesium anodes are the best, in fresh water. In fresh water, they are highly recommended. And let me check in brackish water. No, not recommended in brackish water. Once again, produce overprotection. Okay?